We are going to keep looking at multiplying radicals, but we're going to look at how we can multiply radicals and simplify and bring those two concepts together like we learned yesterday. So first, let's multiply. We have 3 times 2, which we know is 6. So now we can do what we did yesterday. 7 times 21 is 147. X to the third times by x to the third becomes x to the 6th. We add the exponents. And then we have y squared, and there's nothing else to multiply to, so it just stays y squared. So now that we've combined by multiplying, we can break it down. So let's look at 147. We know 147 can be multiplied together by 7 and 21. 7 is prime. 21 is 7 times 3. And those both are prime. So if we rewrite this, 6 square roots, then we have 2 7s, 1 3, x to the 6, y squared. So now we have 2 7s, 1 3, 2 3, 4 5, 6 x's and 2 y's. So if we go to simplify this, we have 6. We can pull out one group of 7s. Can't pull out any of 3's. We can pull out 1, 2, 3 groups of x's. We can pull out one group of y's. So all that's left that we haven't used is our 3. And lastly, 6 times 7 is 42. So we're left with 42 x to the third times y times the square root of 3. So let's take a look at this problem. We have the cube root of 25 x y to the 8th times by the cube root of 5 x to the 4th y to the 3rd. So first, if we multiply, we still have the cube root. 25 times 5 is 125. X times x to the 4th is x to the 5th. Y to the 8th times y to the 3rd becomes y to the 11th. So if we look at 125, we know we can multiply that together by 25 and 5, which is prime, and 25 becomes 5 and 5 as well. So we can rewrite this as the cube root of 5 to the 3rd, x to the 5th, y to the 11th. So we have 3 5s, 5 x's, and 11 y's. 2, 3. So we want groups of 3. We can pull out one group of 5s, pull out one group of x's, 1, 2, 3 groups of y's, and what we're left with is x squared and a y. Let's flip over to the back side. We're going to now focus on dividing radicals. So kind of the same concept as multiplying, except now we're going to be looking at division. So we want to go from 2 radicals to just 1. So we can rewrite this as the cube root of 32 divided by a negative 4. And 32 divided by a negative 4 leaves us with a negative 8. We can find that the cube root of a negative 8 equals a negative 2. And we're done. So then the next example, we have that the square root of 12x to the 4th is being divided by 3x. 12 divided by 3 is 4. X to the 4th divided by x means we are subtracting, so we take 4 minus 1, so we're left with x to the 3rd. And we know the square root of 4 is 2. Here we have 3 x's, so we can pull out one group of x's, and we're left over with 1. And let's look at the last example for today. Rewrite this, so we have the cube root of 162x to the 5th divided by 3x squared. 162 divided by 3 is the cube root of 54. X to the 5th divided by x squared becomes x to the 3rd. Let's factor out 54. 54 can become 6 times 9. 6 becomes 3 and 2, which are both prime. 9 becomes 3 and 3. So here we're left with the cube root of 1, 2, 3 3's, a 2, and x to the 3rd. So if we have 3 3's, a 2, and 3 x's, we need groups of 3, so we have one group of 3's, one group of x's and the square root of 2 left over, or cube root of 2 left over.